Welcome to my channel Mathematics Made Easy by Mary MJ. Today I am discussing class 11 chapter 7 permutations and combinations. We are continuing the chapter. In the last video we discussed about fundamental principle of counting. Now we are moving on to permutations. Permutations. What do you mean by permutation? It is an arrangement in a definite order of numbers taken some or all at a time. What is permutation? It is arrangement in a definite order of a number of objects taken, either we are taking it to all at a time or according to what is that, few, that is if it is told 3 at a time, we will be taking 3 at a time, 4 at a time accordingly. Okay. So what is permutation? A permutation is an arrangement, in a definite order, of a number of objects, taken some or all at a time, In the previous example, in the last video, we took one example, rows. So there are different possible arrangements for this letters. ROSC can be arranged in some other way, ROES or REOS. Like that way, so many different arrangements are there. So each arrangement is a permutation of 4-letter words taken all at a time. So these all are different permutation, the different arrangement taken all at all the 4 letters are taken at the same time, taken all at a time. So all the 4 letters are taken and we are writing different arrangement, different permutations of 4-letter words, 4 letters taken all at a time. So suppose I am taking some other example, number, NUMBER. We need to find out how many 3-letter arrangements are there, 3-letter words arrangement. So we have to take only 3 at a time. So 6 letters are given, 3, 4, 5, 6. 6 letters are given and we have to take only 3 at a time. We are making 3-letter arrangements. So there we can write so many 3-letter arrangements, NUM or BER or UMB, like that way so many arrangements we can make. So these all are different arrangements. Every arrangement is different. Now from here, in this they gave us 6 letters and we have to take only 3. So taken 3 at a time, and the previous one 4 letters are given, all the 4 are taken to make different arrangements. So this is called permutation. It is actually an arrangement. Then, so in order to study permutation, we need to study another notation called factorial notation. Factorial notation. What is this factorial notation means? Factorial notation represents the product of first 10 natural numbers. What is factorial notation? Factorial notation means the notation n factorial. This is called factorial. That symbol is factorial. N factorial represents the product of first n natural numbers. So n factorial means 1 into 2 into 3 into etc. into n minus 1 into n, or in other words we can write just a reverse order, we can write that is n into n minus 1 into n minus 2 into etc. up to 1. This is called factorial notation. That is starting, if it is n factorial, we start with n and find the product up to 1. So what will be 5 factorial? We have to start with 5 and up to 1, that is 5 into 4 into 3 into 2 into 1. So you have to multiply up to 1. You have to take start with which factorial it is asked, from there we have to start and end in 1, find the product of all those, that is called that much factorial. 5 factorial is how much then? 20 into 6. 20 into 6 is 120. Same way then how much will be 7 factorial? How much will be 7 factorial? 7 factorial means 7 into 6 into 5 into 4 into 3 into 2 into 1. So multiply, so that we will get how much is 7 factorial. Then next one question, evaluate 7 factorial minus 5 factorial. What is 7 factorial minus 5 factorial? You can see that 7 factorial means it is 7 into 6 into 5 factorial, because 5 factorial is 5 into 4 into 3 into 2 into 1. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. So 7 into 6 into, we can write as 5 factorial minus last term is 5 factorial. So here in both the cases, first term and last term, we can see that 5 factorial is common, that 5 factorial can be taken outside, remaining 7 into 6 is 42 minus 1. Why this 1 is here? Because 5 factorial means it is 5 factorial into 1, taking the common term outside, we are getting 42 minus 1, and the answer is 5 factorial into 41. So how much is 5 factorial? 5 factorial already we have discussed here. What is 5 factorial? It is 120. So 120 into 41, that is equal to 4920. Then, or you can find out what is 7 factorial, what is 5 factorial, then subtract. Both can be done. Then now another one, compute 7 factorial by 5 factorial. So that is 7 into 6 into 5 factorial divided by 5 factorial. This 5 factorial getting cancelled, the answer is 42. So there no need of multiplying the complete 7 factorial, 5 factorial and all. The common term we have to reach only up to where we are getting the common term. Then what about next one, 12 factorial by 10 factorial into 2 factorial. So as earlier we can write 12 factorial as 12 into 11 into 10 factorial divided by 10 factorial into 2 factorial, then 10 factorial getting cancelled, remaining 2 factorial means 2 into 1, then 2 here cancels. So 12 into 11 by 2 into 1, 2 here 6 times. So the answer is 66. Now next one, evaluate n factorial by r factorial into n minus r factorial when n is equal to 5 and r is equal to 2. So instead of n we have to give 5 and instead of r we have to give 2. So this can be written as 5 factorial by 2 factorial into 5 minus 2 factorial. That is 5 factorial by 2 factorial into 3 factorial, or that is the same as 5 factorial is 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. This 3 factorial getting cancelled, we are getting 5 into 4 by 2 into 1 or 5 into 2, that is 10. Now next one, if 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial. Find x. So, this can be written as 1 by 8 factorial plus 1 by, instead of 9 factorial, 9 into 8 factorial is equal to x by, instead of 10 factorial, 10 into 9 into 8 factorial. Now, in the denominator, the common terms can be cancelled. Together in the denominator, common term is 8 factorial. So, 1 plus 1 by 9 is equal to x by 90. Now, cross multiplying 9 plus 1, 10 by 9 is equal to x by 90, or x equal to 90 into 10, that is 900 by 9. 900 by 9 is 100. So, x equal to 100. Now, if small exercise is there using this factorial, exercise 7.2, that is, first one, evaluate 8 factorial. 8 factorial means 8 into 7 into 6 into 5 into 4 into 3 into 1. Multiply and write the answer. Then next one, question number 2, is 3 factorial plus 4 factorial is equal to 7 factorial. Whether the sum of 3 factorial and 4 factorial is equal to 7 factorial. We will check it. Take the LHS, that is 3 factorial plus 4 factorial, and we know 3 factorial means 3 into 2 into 1, that is 6. 4 factorial means 4 into 3 into 2 into 1. So, 4 into 6, that is 24, that is equal to 30. Now, check for 7 factorial. 7 factorial is 7 into 6 into 5 into 4 into 3 into 2 into 1. 4 into 3 into 2 into 1. That is equal to, here 7 6 are 42. 42 into 20 into 6. And we know that 42 into 20 into 6 is not a number, it is not around 30, it is not equal. Here itself a bigger value. So, 3 factorial plus 4 factorial is not equal to 7 factorial. Then another question. If 1 by 6 factorial plus 1 by 7 factorial is equal to x by 8 factorial, find x. So, as earlier, 1 by 6 factorial plus 1 by 7 factorial can be written as 7 into 6 factorial is equal to x by 8 into 7 into 6 factorial. So, in the denominator 6 factorial is common, that can be cancelled. Remaining 1 plus 1 by 7 is equal to x by 8 into 7 is 56. Then cross multiplying 7 plus 1, 8 by 7 is equal to x by 56. Then 7 here 8 times. So, x is equal to 8 into 8, that is 64. Then next one, evaluate n factorial by n minus r whole factorial when n is equal to 6 and r is equal to 2. So, just substitute the values. So, 6 factorial by 6 minus 2 factorial, which is equal to 6 factorial by 4 factorial, that is 6 into 5 into 4 factorial divided by 4 factorial, and the answer is 30. So, that is all about factorial notation. Now, we have to find how to find out the permutation when all the objects are distinct. We are moving on to permutations. Permutations when all the objects are distinct. So for that there is a theorem related to that. In order to find out the permutation when all objects are distinct, the theorem is the number of permutations of n different objects taken are at a time. That is the number of permutations of n different objects taken are at a time is given by NPR. Number of permutation of n different objects taken R at a time is given by NPR. And what is this NPR? N objects taken R at a time. P stands for permutation. So, and this NPR is n factorial by n minus r factorial, and the value of r lies between 0 and n. So, what is NPR? NPR means n different objects taken R at a time. So, number of permutations is n factorial by n minus r factorial, and the value of r should be between 0 and n. Okay. So, that is when n different objects taken R at a time, that is all the objects are different, no repetitions are allowed. In such a case, we take the formula NPR is equal to n factorial by n minus r factorial in order to find out the number of distinct permutations. Now, this is first one. Theorem 2, number of n different objects taken R at a time when repetition is allowed. This is repetition is not allowed. Repetition is not allowed. In the second theorem, repetition is allowed. So, the number of permutations of n different objects taken R at a time where repetition is allowed. Where repetition is allowed is n raised to r. So, if repetition is not allowed, NPR is equal to n factorial by n minus r factorial. If the number of permutations of n different objects taken R at a time when repetition is allowed is n raised to r. Then one more theorem which you have to study is next one is theorem 3. That is the number of permutations of n different objects where P1 objects are of one kind. P1 objects are of one kind. P2 objects are of second kind. P3 objects are of another kind. And so on. Then the number of arrangements then the number of arrangement is given by n factorial by p1 factorial into p2 factorial, etc. pk factorial. So, the number of permutations of n objects where p1 objects are of one kind, p2 objects are of second kind, p3 objects are of another kind, and so on. How many objects are, how many types are there, etc. Then number of permutations is n factorial by p1 factorial, p2 factorial, etc. pk factorial. I will show you one example related to this. Find the number of permutations. Find the number of permutations. Find the number of permutations of the letters of the word Allahabad. Allahabad. So, here given so many objects are of same type, that is A comes how many times? 1, 2, 3, 4, 4 times. Then L 2 times. Then H 1 time. Then B 1 time and D also 1 time, Allahabad. So, here in this case P1 of one kind. So, A is coming 4 times. Then repetition is here. Okay. So, L is coming 2 times, H is coming 1 time, B is coming 1 time, D is coming 1 time. So, how many different permutations are here? How many different permutations we can find? So, that is n factorial divided by p1 factorial into p2 factorial into p3 factorial into etc. pk factorial, that is equal to n factorial. N factorial, how many elements are here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So, 9 factorial divided by each one repeats how many times? A repeats 4 times. So, 4 factorial. Then L repeats 2 times, 2 factorial. Then remaining all 1 factorial. 1 factorial is 1 itself. So, how many different permutations are here? 9 factorial means 9 into 8 into 7 into 6 into 5 factorial divided by 4. 4 factorial means 4 into 3 into 2 into 1 and 2 factorial is 2. So, 5 factorial can be written as 5 into 4 factorial, because here already denominator consists of 4 factorial, this 4 factorial and 4 factorial can be cancelled, and 2 here 3 times. Remaining multiplying we will get the answer. Answer will be 7560. Number of different arrangements are possible. So, those are the 3 theorems. The first one is if repetition is not allowed, that is NPR, n factorial by n minus r factorial, if repetition is not allowed. Second case, if repetition is allowed, that is n raised to r. Third case, if each one is repeating, given objects itself is repeating, then the number of arrangement is n factorial by p1 factorial into p2 factorial into etc. pk factorial. Okay, now another question. How many 4-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed. So, if repetition is not allowed, how many 4-digit numbers can be formed using the digits from 1 to 9? So, all the digits given is those all are different, that is 1, 2, 3, 4, 5, 6, 7, 8, 9 are the digits given. We have to make 4-digit numbers. and repetition is not allowed. So we can go for NPR. NPR is equal to n factorial by n minus r factorial, and here instead of n, total number of digits given are 9 digits. So 9 factorial divided by 9 minus r. R is 4 digit numbers we have to make. So 9 minus r means 9 minus 4 factorial. That's equal to 9 factorial by 5 factorial, or it is equal to 9 into 8 into 7 into 6. How much is that? 3024 is the number of 4 digit numbers we can make using 1 to 9. Then next one, we have to find out the value of n. Find the value of n such that NP5 is equal to 42 into NP3, where n is greater than 4. So NP5, how can we write NP5? NP5 means n factorial divided by n minus 5 factorial is equal to 42 into NP3 is the same as n factorial by n minus 3 factorial. And we can see that this n factorial is common on both sides, it can be cancelled. Remaining, we can cross multiply this. So n minus 3 factorial is equal to 42 into n minus 5 factorial. Now, what is n minus 3 factorial? N minus 3 factorial is n minus 3 into n minus 3 minus 1 is n minus 4 into n minus 5 into n minus 6 into, going on like that. So we can write this as n minus 3 into n minus 4 into n minus 5 factorial, because this side already we are having 1 n minus 5 factorial. So this is equal to 42 into n minus 5 factorial. Now both sides we can see that n minus 5 factorial is common, that can be cancelled. Remaining n minus 3 into n minus 4 is equal to 42, opening the bracket, n square minus 3n, then minus 4n, that is minus 7n plus 12 is equal to 42. Then that is n square minus 7n plus 12 minus 42 is minus 30 is equal to 0, or what about the values of what n? For that we have to factorize the last term. That minus 30 can be written as minus 10 into 3, and minus 10 plus 3 is minus 7. So we can split the terms, n minus 10 into n plus 3, or n is equal to 10 and n is equal to minus 3, but the number of terms n cannot be negative. N cannot be negative. Therefore, n is equal to 10. So these are the few things which we have to study in this exercise, in this that is theorem 1, 2 and 3, that is when repetition is allowed, repetition is not allowed. If the objects itself is repeating, how many different arrangements are possible. So permutation means it is a definite arrangement. So first you have to understand that, and how to use, where this factorial notation is used. These all you have to keep in mind while doing the problems. Thank you for watching my video. Those who haven't subscribed, please like, share and subscribe, and also click on the bell icon for more updates and notifications. Bye.